Hi, we're going to talk about oscillation tank circuit. The oscillation tank circuit is nothing but a serial combination of an inductor and a capacitor that is called tank assertive or oscillatory circuit, which produce continuous oscillation. The operation of a tank circuit involves an exchange of energy between kinetics and potential. Oscillations works because they overcome the loss of the feedback's resonator circuit either in the capacitor, inductor, or both in the same circuit by applying DC energy at a required frequency. In other words, an oscillator is an amplifier which uses positive feedbacks that generates an output frequency without the use of an input signal. Equation of a tank circuit. First, we equal the inductor and capacitor voltage, and we use the time equation. Then we replace them in the differential form and interval form, and then we derive by both sides. Here we change the current in time by Euler ST. Then we find the two roots and we replace them in the current equation. For make a new current equation here, and then we replace the initial current in the equation and we find the capacitor voltage and inductor voltage.
I'm going to talk about how can the resonance frequency of an oscillating tank circuit be calculated. We will consider a certain time t after which the switch is closed and the current and charge is less than the max. So this means that at this time both of these elements store energy and the sum of them is the total energy of the LC circuit at time t equals 0. The total energy is capacitor plus inductor energy. Derivate the energy by time and replace where we derivate for second time by time, and we need also the general charge and derivate by time. The expression finally is the frequency is 1 over 2p square root LC. I'm going to talk about the application of a tank circuit. The most common application of tank circuit tuning radio transmitter and receivers. For example, when we tune a radio for a particular station, the LC circuits are set at resonance for that particular carrier frequency. The voltage modification. The effects of voltage modification are particularly useful as they can provide modification of IC without need for an external power supply. The load impedance in output circuits or RF amplifiers. Due to high impedance, the gain of amplifier maximum resonance frequency. Why do we use an oscillating tank circuit in the RF transmitter? Explain the use of a variable capacitor. To generate the radio frequency carrier waves, FM transmitter circuit requires an oscillator. The tank circuit derivates from the LC circuit to store the energy for oscillations. The input audio signal from the mic penetrates to the base of the transistor, which modulates the LC tank circuit carrier frequency in FM format. The variable capacitor is used to change their frequency for fine modification to the FM frequency band.
Is it possible to use an oscillating tank circuit for AM transmissions? In general, the transmitter operates with assigned frequencies or channels, and the crystals provide the best way to obtain the desired frequency with good stability. Typically, LC oscillators do not have the required frequency stability to stay on frequency variations. Typically, variations in temperature and other conditions cause the frequency to exceed the limits.